Hey there guys, here we're looking at past paper exam questions involving shaded area, which is a very common type of question. All the questions here are suitable for both foundation and higher, except the last question, which is very much higher only. Remember, you can download the questions from the description down below to try yourself or play along with the video. Okay, let's go. Hey there guys, welcome back to the channel. If this is your first time here and you're trying to get the best grade in maths you possibly can, let me help. Start now by subscribing. Then first up, here is a circle touching a square. The area of the square is 64 centimeters squared. Work out the area of the circle. Give your answer in terms of pi. Okay, so the first thing we can do here is work out the side length of the square. And that's going to be the square root of 64, which is 8. So, the side length of the square is 8 centimeters. Now, the formula for the area of a circle is pi times the radius squared. Now, the radius of the circle is going to be half the side length of the square. So the radius of the circle is 4 centimeters. So then the area of the circle is pi times 4 centimeters squared. Now that is going to give us 16 pi centimeters squared. Okay, next up, the diagram shows a square ABCD of side length 20 centimeters. It also shows a semicircle and an arc of a circle. AB is the diameter of the semicircle. AC is an arc of a circle, centre P. We want to show that the area of the shaded region over the area of the square is pi over 8. Okay, so we need to work out some areas. So first up, let's do the square. So the square, it's nice and easy. The square is going to be 20 centimeters times 20 centimeters, which is 400 centimeters squared. Cool. Okay, now the bottom part of the square under the arc AC is a quarter circle. So the shaded bit and the semicircle both together make up a quarter circle. Now the quarter circle then, I'm going to call QC. So, quarter circle with a radius 20 centimeters. Now, if we had the whole circle, the area would be pi times 20 centimeters squared. So that would be pi times 400 centimeters squared. that we have a quarter circle. So the quarter circle is then going to be 100 by centimeters squared. Okay, and then the semicircle has a diameter of 20, so it has a radius of 10 centimeters. Now this is half a circle. So the semicircle is going to be pi times 10 centimeters squared over 2. So that's pi times 100 centimeters squared all over 2. So that is 50 pi centimeters squared. Okay, now what this allows us to do is we can now work out the shaded area. So the shaded area is the quarter circle minus the semicircle. So that's going to give us 50 pi centimeters squared. Okay, so now finally we have everything we need for the fraction. So the shaded over the square is 50 pi over 400. Now that has a common factor of 50 and does indeed simplify to pi over 8. Okay, next up, 4 identical circles just fit inside a square as shown. Work out the shaded area, give your answer in terms of pi. Okay, so think of a square as a sheet of pastry and we're cutting 4 circles out of it. We want to know the area of the pastry we have left. So, first thing we need is the area of the square. So that's 12 times 12. So 12 centimeters times 12 centimeters is 144 centimeters squared. Now, then what we need to know is the area of one of the circles. So, this diagram is very symmetrical. So, the diameter of one circle is going to be half the length of the square. So the diameter is 6, which means the radius is 3 centimeters. So the area of a circle is pi times 3 centimeters squared. So that's going to give us 9 pi centimeters squared. Now we have 4 circles. So that's 4 times 9 pi centimeters squared, which is 36 pi centimeters squared. Now finally, the shaded area is the square, so 144 centimeters squared minus 36 pi centimeters squared. And that's it, because they want it left in terms of pi. Okay, next up, A shaded semicircle is inside a bigger circle as shown. The radius of the circle is 10 centimeters. The diameter of the semicircle is 8 centimeters. How many times bigger is the unshaded region than the shaded region? Okay, so we're going to need the area of the circle, the area of the semicircle. From that we can work out the unshaded region and all live happily ever after. So the circle is going to be pi times 10 squared, so that's 100 pi centimeters squared. Now for the semicircle, be careful there because we are told the diameter is 8 centimeters, so that means the radius is 4 centimeters. So for the semicircle, the radius is 4 centimeters. So the area, now remember it's a semicircle, so the area is pi times 4 centimeters squared, so 16 pi centimeters squared, divided by 2. So that is 8 pi centimeters squared. Okay, so now we can work out the area of the unshaded region. So the unshaded is 100 pi minus 8 pi which gives us 92 pi centimeters squared. Now, we want to know how many times bigger is that than the shaded region. So that is now a division. So we're now doing 92 pi divided by 8 pi. Pi's cancel, so it's 92 over 8. Now for that we can use with a bus stop. So 92 divided by 8. So 8 into 9 go once, 1 remainder. 8 into 12 go once, 1 remainder. So we now put a point 0 on the bottom and a point on top. So we carry the 4. And then 8 into 40 go 5 times. So the answer is 11.5. Okay, next up, a bit of a strange one. So we have two squares A and B. The side length of A is 50% less than the side length of B. We want to express the shaded area of A as a percentage of the area of square B. Okay, so the first thing to do with a question like this is pick numbers that work with what we're given. So, the side lengths of A are 50% less than the sides of B. So, if we pick a 1 as the sides of A, that means the sides of B would be 2. Now, from that, we can work out the area of A. So that would just be a 1 square unit, which means the area of the shaded part it's going to be a half of that, so 0.5. And the area of B is going to be 2 times 2, so 4. So, the first thing I would now do, we want the shaded region as a percentage of B. So I would first of all turn this into a fraction, so it's going to be 0.5 over 4. Now that, if we really now we'd want to turn the top into a whole number, so if we multiply top and bottom of this by 2, we get a 1 over 8. Now there are a few ways now that we can think about turning this into a percentage. So I'm going to use the bus stop to turn it into a decimal because it's good practice, and then turn that into a percentage. So 1/8 means 1 divided by 8. Now 8s into 1 don't go, so we put a 0.0 on the bottom with a point on the top, and now carry the 1 onto the 0. Now 8s into 10 go once, remainder 2, so we need another 0. 8s into 20 go twice, remainder 4, so put another 0. And then 8s into 40 go 5 times. So we have 0.125. Now to turn a decimal into a percentage, we multiply it by 100. So this is 12.5%. Okay, next up, so this one is probably a bit tricky. So we have a rectangle inside of a semicircle. The dimensions of the rectangle are 16 by 6 centimeters. We want to work out the shaded area, giving our answer in terms of pi. Okay, so to work out the shaded area, we're going to need the area of the semicircle minus the area of the rectangle. So the rectangle is 16 times 6. So 6 times 10 is 60, 6 times 6 is 36. So that's 96 centimeters squared. Okay, now the biggest problem is how do we now work out the area of the semicircle? Well, this diagram is very symmetrical. There's a line of symmetry going down the middle. So if we cut this rectangle in half, we know this guy is going to have a length of 8 and a height of 6. Now because of the symmetry, the line coming from here to the corner of the rectangle is the radius of the circle. So we've made a right angled triangle, so we can play Pythagoras. So if we call this guy C, by Pythagoras, 8 squared add 6 squared is equal to C squared. So 64 and 36 is C squared, 100 is C squared, therefore C is 10. So the radius is 10 centimeters. So now we can work out the area of the semicircle. So the semicircle is pi times 10 squared over 2. So that's 100 pi centimetres squared divided by 2, which is 50 pi centimetres squared. So finally, we can now get the shaded area. It's the semicircle minus the rectangle. So the shaded area is 50 pi centimetres squared minus 96 pi centimetres squared. Now the final question. Now this one is very much higher only. It's 6 marks and it involves Pythagoras and SURDS. Yay. So the diagram shows a right-angled triangle. 4 of these triangles are used to make a shaded square as shown. Our job is to work out the area of the square, giving our answer in surd form as simply as possible. Okay, so area of a square. How bad can that be? Well, pretty bad. So, we need to work out the side length of the square, which we can see is part of the base of these right-angled triangles. Now, at the moment, we don't know the base of these right-angled triangles, so that's the first thing we're going to work out. So, if we call the base B by Pythagoras, we know 4 squared at B squared is 6 squared. Okay, so that gives us 16 at B squared is 36. So B squared is 20, which means B is root 20. Okay, now I'm going to leave it like that at the moment. It's probably going to be easier to deal with than if we simplify it. So the base of the triangle is root 20. Okay, now the side of the square is not the whole of that root 20. So we know from here to here is root 20, but we know that from here to here is 4. So that means the side length of the square from here to here is root 20 minus 4. So, now that we know that, the area of the square is root 20 minus 4 times root 20 minus 4. So now it's just a game of surd expansion. So we don't need the diagram anymore. Now to do surd expansions, I would highly recommend using a table. So one bracket across the top, the other one down the left. Okay, now root 20 is 20. Minus 4 times minus 4 is 16. And then minus 4 times root 20 is minus 4 root 20. So, altogether we have 36 minus 8 root 20. Okay, so we're almost there. What we now need to do is simplify 8 root 20. So this is 36 minus 8 root 4 root 5, which is 36 minus 8 times 2 root 5, which finally is 36 minus 16 root 5. And there it is. So if you want to see it all together, there it is. If you want more exam questions on SURDS, then I do have a video. I'll link that down below. Hey then, your heroes, that's all the fun for this video. I really hope you found it useful. If you have, please do give us a thumbs up and get subscribed. If you have any requests for topics you want done like this, let me know down below in the comments. Remember, there are separate playlists for higher and foundation with exam questions on all sorts of topics. They are linked down below. For now, take it easy, take care.